Some of the more technical, meaty notes of today, when I talk about teamwork, is effective use of branches in version control. Branches really do help make the process of working as a team simpler and more convenient. So by now in your projects, you've probably used Git branches in some form. And for this class, we're using Git, but branches exist in pretty much every form of version control. How do you develop as a team? Well, you could develop all on one version, the master or main branch, what used to be called the trunk. But today, creating branches is cheap. They don't cost anything. They don't take up space. They're instantaneous to create, and you could delete them at will. The idea is that we're going to separate commits and feature choices per branch. So when we make a new branch, this should have a related set of commits to that branch. We're going to merge them back into the main branch. And hopefully we're going to do so frequently such that we incorporate our changes as our branch gets changed and as the main branch gets changed. And in our SaaS applications, we're going to say sort of the killer use case for branches is what we call branch per feature. Sometimes GitHub calls this the GitHub flow. But the way that we think about this is, how do we create features without breaking things in our existing app? How can we as a team be working on 2 or 3 or 4 things in parallel without causing too much trouble? So when we're about to work on a new feature, we make a new branch just for that feature. We're going to use the word feature here, but this applies to bug fixes, it applies to chores, it applies to whatever kind of development work we might be doing. The idea here, right, is that we're going to ideally be working on our own feature at one feature at a time. Our teammates in parallel will be working on their features. We're going to use this branch only for these feature changes, and then we're going to merge that branch into the main branch. We'll then delete the branch. This allows us to do things like, if something goes wrong, back out or revert those changes, because Git's branches allow us to keep track of all of those commits in a single entity. And we'll sort of say, in a well-factored app, ideally, one branch shouldn't be touching too many parts of the application. That if we're adding a feature, what we're doing is adding those features in a relatively isolated set of places. We might still be touching our models, views, and controllers, but hopefully we're doing so in a way that isn't going to create a bunch of conflicts. You might also decide, as you're working on features, that some code refactoring needs to happen. How do you think about this? Well, you make a branch due to the refactoring, you merge in the refactoring branch, and then now you make the adding a feature branch really easy to do, and you merge in that branch separately. So branching is cheap, and it's something that the more you get used to it, the easier it becomes. So what are the daily mechanics of a branch? I do say daily because the more frequent you do this, the easier they can be. So code here as a reference, but no need to memorize it, although you should sort of get used to it. Check out a new branch and switch to it. You could do git branch, new feature for the branch. You could do git checkout of the branch. You could also do git checkout -b to switch to the branch. On that branch, you should edit, add, make commits to that branch as you work, like normal. Again, what's a good commit? Keep the changes together, make sure that tests are passing, so on. Do that as you would normally. You're going to push the branch probably to the origin repo. Sometimes you could skip this depending on your team's working style, but typically that's going to be pushing it to GitHub. Git push origin your branch name. This will create that branch on that remote that everyone can access. Or in the case of Heroku, right, if you're deploying it, this is going to deploy that branch to Heroku. Afterwards, you're going to switch back to your main branch, then merge those changes in. So you could do git checkout main. And then you could, the final step, git merge your branch name. So be careful here, right? When you're using a command like git merge, that is the step which actually incorporates the changes into that particular branch. Up until this point, Git is keeping track of your changes on 2 parallel branches. Nothing in the main code base has changed yet. But the second you do that merge is the point at which you're sharing that code with your teammates. Branches often work locally. They're easy to check out. You might hopefully check them out frequently. But also when you work on a team, you typically want to share this code with others. And so this is where rebasing and pull requests come in. And we'll talk specifically about pull requests in a moment. Rebasing is a Git technique which allows us to sort of pretend that a branch came from another point in time. This is particularly helpful as work happens in parallel. You want to make sure that the history of that Git commit maintains sort of a flow. So rebasing allows us to say that as I've been working, my teammates made some other work which I would like to incorporate into this branch. You can rebase them such that it's clear the order of time in which those commits happened. You still need to resolve merge conflicts or conflicts between your code when you rebase, just as you would with a regular Git merge. But using rebase allows you to incorporate those changes a little bit more frequently and with more intentionality. Going back to the idea that if something hurts, you should do it more frequently. Rebasing your code will seem complicated, but doing it more frequently makes that process easier. And importantly, the more frequently you keep branches in sync with each other, the fewer conflicts that you'll ever have to deal with. The best kind of merge conflict to resolve is the merge conflict that doesn't exist. And you can get there by frequently doing things like rebase your code. Once you've cleaned up your branch, once everything's ready, that's when you get to push your code up to GitHub and make the pull request, or do something like merging into the master branch. And if you've done the rebasing step, that means that that final merge will be what we call clean, or there'll be no conflicts, nothing to resolve. It'll be sort of one click, easy to merge. And this is super helpful, right? Because when you or your teammate click that merge pull request button, if you're doing it through GitHub, you want to be sure that as that code goes out into the world, nothing else is going to break. So why do we do this instead of just merging directly? Keeping that Git history up to date really helps avoid the most challenging of conflicts. So pull requests. People always get confused by the name, sort of naturally. The way to think about a pull request is that you are requesting that someone else pull your code into their repo or into their branch. So sometimes you're requesting to yourself that you pull the code in if you're working on your own branch or your own team. But the way to think about this with GitHub is pull requests apply within a repo and between repos, and we'll talk about that in a moment. PRs don't need to be made to the main branch. They can be made to any branch in the repo. We'll talk about where we might use this for development or deployment branches. But remember is that when we're working with Git branches, we're really thinking about where am I working on this feature? Where should the code for this feature live when it is all merged in? And so you should pick the most appropriate destination for the task. Each pull request will come with a description and a text box, which you should fill out with the details of that pull request. And what we'll talk about later is, especially with GitHub, pull requests provide the hooks for automation and tools. When we talk about continuous integration, pull requests are often today the starting point for let me run all of my tests, let me look at a series of test results, make sure everything's okay, let me have a discussion on that code. We'll specifically talk about code review later. Merging a pull request through GitHub is the exact same thing as doing Git merge, and GitHub or other Git tools will guide you through that process if something is non-trivial. But typically when you click that hopefully green button on GitHub that says merge pull request, all it's going to be doing is what you could do locally with Git merge. Pull requests as code reviews. Opening a PR is a great way to start the process of a code review. Most working software engineering teams today use version control and some sort of pull request as the mechanism for code reviews. At Google, when someone checks in code, it doesn't get merged in until someone comments LGTM or looks good to me. And you may have seen this elsewhere on GitHub. Publicly, this comes typically from Google. In the spirit of automation and making things easy, LGTM is a special phrase that actually triggers a bunch of actions and audits and checks and merging that happens in some of their tools. And Depending on the particular pull request, you can close a pull request or you could revise it before merging. The aspect of opening a pull request does not need to be the final state of that code. You should think about it as a conversation for that code. GitHub's developers also sort of exclusively work this way. If you're curious, there's a great talk. It's a few years old now, but it's called How GitHub Uses GitHub to Build GitHub. Good advertising, for their own company, but they use GitHub, the same tools that we do every day, to improve the product itself. And pull requests are a great tool for that.
Yeah, pull requests are amazing. And if you take 169L with us in the fall, you will also work exclusively this way because we will make you do it. But one of the reasons that when we talked about user stories and stuff like that, and I said, I'm really big on 1-point stories. Like there's no such thing as a story that is too small. A 1-point story means probably not a lot of changes to the code, which means that when you open a pull request for somebody else to sort of look at your code with a second pair of eyes, you're not asking them to look at like hundreds of changed lines, right? A pull request that is enormous is almost useless because it's really hard for someone else to look at it and actually understand if your code is any good or not. But if you're talking about there's only 3 or 4 files changed, there's only a couple of tens of lines, that's very different. So how does code get to a place where you have 1 million bugs? It gets there 1 bug at a time, right? And pull requests are a really good mechanism to sort of be a safeguard against that. But they only work if the amount of work you're asking someone to do to review your pull request is a reasonable amount of work. And the way that happens is you keep the request small, and that's why I like small stories and chunking up work into small pieces, because then you can get sign off on like every little piece, and it's much harder for those bugs to sort of creep in and leave you in a bad place. So, yeah. But yeah, I think, if you compare Git, the version control system, versus GitHub, the service that allows you to maintain Git repos, pull requests are basically a GitHub invention, if I'm not mistaken. They're not part of Git itself. They're a feature of GitHub that helps you manage repos, and I think they're brilliant. I think it's like the single best thing about GitHub as a service backend for version management is this. It lets you have this flow where people are sort of reviewing each other's code like all the time.
One thing I'll say about that is, I wish there were a metric, but probably doesn't matter because all metrics have subheading, is code review time increases nearly exponentially. It might not actually be exponentially with lines of code, but as that pull request grows, it takes longer and longer to review. In the case of 169L, your code review will come primarily from your teammates, but Armando and I, and whomever our TAs end up being, will also be there to review your code throughout the semester. If you make those pull requests smaller, then we have much more opportunity to give you an effective review on those pull requests. Invariably, the most frustrating experiences I've had as an engineer have come from pull requests that should have been smaller, but either couldn't be or weren't for various reasons. These things, do happen, right? But the smaller and the more disciplined they are, the easier it becomes to make those pull requests. We'll talk about techniques later, but you don't have to start off writing your code knowing that it'll be a small pull request. Sometimes you make a lot of changes, and then we'll talk about how you extract those commits in a bit to make future smaller pull requests. And then the other final thing that I'll say is that this applies to lots of things. If you need to send an email and ask someone, for some bit of information, shorter emails that are more, concise and easy to read, that have fewer requests in the email if possible, get responses faster. Code reviews that are more direct get more review more quickly.